I respect you all. My name is Senthilkumar from JJ College of Arts Sciences, Autonomous Pudukkottai. My research topic is structural, microstructural, and optical properties of cobalt over zinc and nanostructure. Structure of the project, scope of the research work, definition of the problem, characterization techniques, result and discussions, conclusions. To investigate the characteristics of cobalt over zinc nanoparticles using chemical method, to examine the structure, particle size, morphological properties, optical properties, characterization techniques. The different type of characterization techniques are given. First one is X-ray powder diffraction XRD. Second one is field tension scanning electron microscopy FESM. Third one is energy dispersive X-ray spectroscopy EDAX. Fourth one is UV visible NIR spectroscopy studies UV. Last one is photoluminescent spectroscopy PL. Result and discussions. X-ray diffraction pattern. The standard diffraction speaks to the hexagonal woodford structure of cobalt zinc nanoparticles. The average particle sizes ranges between 24 to 26 nanometer. Next one is a FESM image. The shape and size of the nanoparticles give important regarding nanoparticle shape. And the zinc oxide nanoparticles forming a spherical structure. The particle sizes of the cobalt zinc nanoparticles are decreased as compared to the zinc oxide nanoparticles. This reduction in particle size is due to the discharge is cost material incorporated with cobalt 2 metal ion. EDAX analysis. From the EDAX analysis, the concentration of cobalt is found to be 0.71 respectively. The chemical composition of zinc and oxygen found to be 48.76% and 51.24% for cobalt zinc nanoparticles. In pure zinc nanoparticles, only zinc and oxygen ions are detected. Next one is the UV visible spectroscopy studies. The absorption peak edges are observed at 327 nanometer, 320 nanometer, 370 nanometer and 32 nanometer for zinc and cobalt zinc nanoparticles respectively. The band gap are observed at 3.4 electron volt, 3.44 electron volt, 3.47 electron volt and 3.37 electron volt for zinc oxide and cobalt zinc nanoparticles respectively. The cobalt zinc nanoparticles band gaps value are increased as compared to that of pure zinc nanoparticles. The increases in the band gap or fuse effect can be explained on the basis of the Brewster-Mohs effect. PL spectra. The photoluminescent spectra of the untouched zinc oxide and cobalt nanoparticles recorded with the excited wavelength of 325 nanometer. The PL emission is observed for zinc oxide samples covering from the very short wavelength of 350 nanometer to long wavelength 600 nanometer. From the PL spectra of untouched zinc nanoparticles, near band edge emission wavelength is observed at 380 nanometer. This is due to UV peak correspond to the radiative recombination of the Phi exciton collision process in the zinc nanoparticles. Last one is a conclusion. Cobalt zinc nanoparticles were synthesized by chemical method. The X-ray diffraction study confirmed the hexagonal woodford structure. From the FESM image, cobalt zinc nanoparticles were exhibited spherical structure. The average particle sizes were observed in the nanoscale range. From the EDAX analysis, in the chemical composition were estimated. The band gap of pure zinc nanoparticles, cobalt zinc nanoparticles were estimated as 3.45 electron volt, 3.45 electron volt, 3.47 electron volt, and 3.375 electron volt by UV visible spectroscopy measurements. The photoluminescent studies show that the doping with zinc nanoparticles will alter the band emission due to the zinc vacancies, oxygen surface defects. Thank you all.